Hi, it's Mr. Anderson, and in this video I'm going to talk about logistic growth. You should probably watch my video on exponential growth if you haven't done so first. But logistic growth is what happens after. In other words, after a population eventually maybe crashes or finds a natural kind of a carrying capacity. And so let's start by talking about population growth in general. Imagine we have 2 rabbits. Our n value is 2, so n is always going to refer to the population size. Now it's going to change over time, but to start, let's say n is equal to 2. R is going to tell us how fast that population is going to change, and we call that growth rate. It really is determined by 2 things, births and deaths. And let's say that these rabbits have 2 baby rabbits, and so we'd have 2 births minus 0 deaths, so that's going to be 2 minus 0, or 2, and then we divide it by our original n, which was 2, so it's going to be 2 over 2, or 1. And if you have a growth rate of 1, things are going to go really, really quickly. But we could have had a growth rate of 0.5. How could we get that? Let's say 2 rabbits are born, minus 1 dies, so that would be 2 minus 1, or 1, over 2, and that's going to be 0.5. The take-home message about exponential growth, remember, is if r is ever greater than 0, we're going to show fast exponential growth. And so let's say it's 1. What's going to happen? Well, those 4 rabbits are going to become 8. And then we're going to take 8, in this case, times that growth rate of 1. And so we're going to now have 16. And now we're going to have 32, and now we're going to have 64, and we're going to have 128, and we're going to have 256. And pretty soon, my whole screen is going to be filled with rabbits. And I heard my fan come on my computer because it's really taxing to put that many rabbits on the screen. And so does that occur in nature? No. And Darwin noted that as well. He looked at, instead of rabbits, elephants. Elephants take a long time to reproduce. In other words, they have to be 30 before they can reproduce. And they live till they're about 90. And what he found is that even though they might produce 3 pair of offspring during that period of time, if you just let them keep breeding over and over and over again, after 5 centuries or 500 years later, you're going to have 15 million elephants. And so exponential growth goes really, really quickly. And we know that it can't last forever. Eventually, we're going to hit a limit. And so let's look at those 4 rabbits again. Eventually, they're going to reach what's called K, or carrying capacity. It's the maximum amount in a population that it can be supported in a general kind of in an ecosystem or in an area. And so why is that? Well, rabbits eat things, and that is grass. And when they run out of grass, they die. Now, I don't have the ratio right. You have to way more producers than you're going to have consumers. And so let's put our rabbits on the grass. What are they going to do? They're going to eat the grass, and as they do so, that grass is going to go away, and they're going to have to move on to another area. And so luckily, there's more grass for them to find. But eventually, they'll eat their way into a corner. So this rabbit right here has a problem. If this grass didn't grow back, it would really be stuck. And so if we had much more than 4 rabbits, we would have exceeded the carrying capacity. And in class, I asked my students to build models that showed logistic growth. And a lot of them used paper and pencil, but one creative group used Minecraft. And what they did is they constructed a little chamber here, and they put 1 chicken in. And every time the chicken would step on one of these platforms, 2 doors would open up, and 2 more chickens would come out. So pretty soon we had 3 chickens. And they'd step on platforms, and pretty soon we had 5 chickens, and it just went really, really, really quickly. Pretty soon there were chickens everywhere. And I asked them, well, it's got to show logistic growth. And these bright students, Gabe, Ethan, and David, said, well, watch what happens. Eventually, as they stand on the platforms, it becomes so crowded, they can't get off anymore. And so they can't release any more chickens into the area, and so eventually it reaches kind of a carrying capacity of chickens in this 1 container. Now let me show you another model. This is a net logo model called Rabbits, Grass, and Weeds. So let me launch that for a second. So in this model, the rabbits are going to be these little white things with ears, and then the grass are going to be these little green squares. And so we start with 5. Now the rabbits are going to find grass if they can. And if they can, they're going to get energy, and if they get enough energy, they can breed. But if they don't find enough grass, then they're going to die. So if we let it go for a second, it goes really, really quickly. So let me stop it there for a second. So let's watch what happens. And so this red line here is going to represent the number of rabbits over time. And so again, we started with 5, and pretty soon we had 350 rabbits. What happened to the grass? Well, the grass started to reproduce as well, but it crashed because the rabbits were eating all the grass. And so let's watch what happens now if we let it roll for a second. So we're going to see a big drop in the number of rabbits, and then it's going to finally hit a limit. So we're going to find like a perfect amount of rabbits that we have. So we're reaching what's called carrying capacity. And you can see that if we let it go over and over and over, the grass and the rabbits are going to go up and down, but we're going to reach a limit. Now let's say that we gave the grass more energy. So if there's more energy in the grass, let's increase that, we're going to see exponential growth again. And then we're going to have even more rabbits. Or let's say we said that the grass has less energy. As we decrease that, then we're going to have way fewer rabbits. And so that rabbit population is going to drop, but it's going to find another carrying capacity. So what happens as your population size increases? You run up against these limiting factors, and those limiting factors are going to slow your